Let's have a look at the constructions of images of convex lenses. So, just remind ourselves that we can put an object, bring a line in that is parallel to principal axis, goes through the focal point, or we can bring something through the other focal point and it will then go parallel with the principal axis. But this is my preferred line. It is so simple to draw and it is so effective in forming those images. This would be my first one, and then this would be my second. Once we have those two values, where they cross is where the image, if any is formed, forms. Combining any two rays gives you that location. So there's that nice little sweet spot. Has no effect whatsoever. Could put this one in, or we could quite easily put the other one in that comes out of here and goes through here, and it will still meet at that location. There's my preferred line. Four types of images produced by convex lenses. Similar to the exercise that we did with mirrors, it's absolutely important, if you wish to get good marks, that you understand how each of these images are formed. Twice the focal length. So twice the focal length has got to be the centre of curvature. First line, you can quite easily bring either of those two lines in, and the third line that goes straight through. Any two forms that image, and we call it real because it's inverted and it's smaller than the original, so it has got to be diminished. So at twice the focal length, that's at the centre of curvature, and the straight line that goes through undeviated. It's real, inverted, and is the same size. Between 1 and 2 focal lengths, so that's between the centre of curvature and the focal length. That's my preferred line, along with this one, and we get ourselves an image that is going to be real. If it's real, it's got to be inverted. So if you see an inverted image, you know it's real. And it's bigger than the original object, so it has got to be enlarged. It will have a positive magnification. Closer than the focal point, that's my preferred line. Along with this one, and you notice that these two lines have got arrows pointing on them, and these two are not parallel. So if we put dotted lines behind, this is the classic of a magnifying glass. So if we had an eye that was in this area here, the eye would follow those lines back and they would see an image that was bigger than the object, but it was happening behind the lens. So we say that this image is virtual because it's upright and it's enlarged. It has a positive magnification. So when we look at concave lenses, we'll look at that in the next video.